Now we're going to look at two-dimensional net force equations again, and this is example 2. So we have Stephen pushing a 20-kilogram lawnmower. The grass and ground provide a friction-type resistance that is equivalent to 275 newtons. If Stephen pushes the lawnmower with a force of 300 newtons, directed 30 degrees below the horizontal, what is the magnitude of the normal force and what is the acceleration of the lawnmower? So of course we start with our picture. So we have our ground that should be flat, our lawnmower, and then our lawnmower is being pushed at an angle. There's Stephen pushing the lawnmower. And now to draw our application of force, let me change colors. And we're going to start with that 300 Newton pushing force. Well, to figure out what direction that force is, we're going to follow the push through the lawnmower and then draw the arrow coming out the bottom in the same direction. This is going to be our 30 degrees below the horizontal, and this is going to be our force, our pushing force, F. Now the other forces that we have the friction type resistance, which is going to be opposing motion and parallel to the surface. Since it's moving, it's kinetic friction. We are going to have the support force, our normal force, that's always perpendicular to the surface. And then we are going to have our gravitational force, or weight force, that always points straight down. So now we're going to create our free body diagram. We're going to take these forces and put them straight on a dot. So we have our pushing force, we have our normal force, we have the weight force, and we have our friction. We don't know exactly what the magnitudes of these forces look like relative to each other, so we're not going to worry too much about their magnitudes or the size of the arrows. Now we're going to say up is positive and to the right is positive. So down negative, to the left is negative. Now we need to do that extra step that we had in our instructions. We need to take our force that is at an angle and come up with its components. But one thing to never do, never put the components on a free body diagram. If you are doing a free response question and you put the components of this angled force on your free body diagram, you will lose credit. So what you do is you draw it separately to the side. There's our force, and we need our horizontal component, which will point in that direction, and our vertical component, which will point in that direction. The horizontal component is always equal to our force times the cosine of the angle, and here's our angle. The vertical component is always equal to the force times the sine of the angle. So there's our component equations. Now we go back to the same steps we've always done, and we're going to do the knowns and what we're looking for. So what do we know? From the problem, we know the mass of the lawnmower is 20 kilograms. We know that the friction force is equal to 275 newtons. We know that Stephen is pushing 300 newtons. We know the angle is 30 degrees. And those are all the numbers we have, but of course we know little g. And then what is it we're looking for? We are looking for the normal force, and we are looking for acceleration. All right, so now we are going to do our two net force equations. So we have our vertical net force equation, and then we are going to have our horizontal net force equation. So let's start with the vertical. Well, this lawnmower is not moving up, it's not moving down. So the acceleration vertically is going to be 0. So the vertical forces are going to add up to 0. So now we're going to write down all of the forces that have any part or any component on the vertical axis, the y-axis. So we're going to start with our normal force, which is pointed in the positive direction. Our weight force, which is pointed in the negative direction. And then we have the vertical component, the y component, that is pointed in the negative direction. So there's our initial net force equation. Now we know that we're looking for the normal force. The weight force is not a known. The y component is not one of our knowns. So we need to substitute some of our specific equations. So we know that the weight force is mg, and the y component of our force is equal to F sine theta. Well, we're looking for the normal force. We know mass, we know acceleration due to gravity, we know the pushing force, we know theta. We now have enough information to solve for our normal force. So the normal force is equal to mg plus F sine theta. Plugging in numbers, we have our 20 kilograms times 10 meters per second squared plus our 300 newtons times the sine of 30 degrees, and our normal force will equal 350 newtons. So next, we're going to do our horizontal net force equation. This one, we are looking for our horizontal acceleration. So we're going to go straight into writing down our forces, our horizontal forces. So in the positive direction, we have a component of the pushing force, the x component, and that's pointed in the positive direction. Kinetic friction is pointed in the negative direction, and it's going to equal mass times the horizontal acceleration. So we are looking for acceleration. We know mass, we know friction, we do not know the horizontal component of our force. So we have to substitute our component. So it's going to be F cosine theta minus friction equals ma. Again, we are looking for it. We know it, we know it, we know, we know. Now we have all of the information to be able to solve for acceleration. So we can rearrange the equation. Basically, all I'm going to do is divide by mass. I just rearranged it so that the acceleration is on the left. Now I'm going to substitute numbers. And when I do the math, I'm going to find that my acceleration is going to equal negative 0.76 meters per second squared. So in this case, since my velocity is going to be in the positive direction, it's moving in the positive direction, I am going to, or the lawnmower is going to be slowing down. The acceleration is in the negative direction.